In exactly 48 hours, something extraordinary happens that NASA has been quietly preparing for. An object travelling at 137,000 mph from another star system will pass within 29 million kilometres of Mars. But here's what they're not telling you. Harvard's Avi just rated this object a 6 out of 10 on his scale for potential alien technology. That's 60% confidence. It's not natural, and when you see what amateur astronomers just photographed, you'll understand why the scientific community is in absolute chaos. Because this isn't behaving like any comet we've ever seen. It's releasing pure nickel without iron. That's impossible in nature. It only happens in industrial manufacturing. Its chemistry is 16 times more extreme than any known comet. It turned from red to green overnight. And its trajectory has a 1 in 500 chance of being random. But here's where it gets terrifying. In late September, 3 Atlas disappears behind the Sun for 2 months. We won't be able to see it during its closest approach on October 30th. Lowe suggests this could be intentional to avoid observation when it's brightest or when something else happens. Some scientists believe it may have already deployed invisible precursor probes too small for Earth telescopes to detect that could reach Mars while we're all watching the main object. Over 227 observatories worldwide have tracked this thing. They've compiled over 4,000 observations, and every single data point makes it stranger. At 33 billion tons. It shouldn't exist. The math doesn't work. We should have found 100,000 smaller objects before finding something this massive. So, what the hell is 3E Atlas in the next hour? I'm going to show you every anomaly, every leaked observation, and every theory scientists don't want to discuss publicly. Because after October 3rd, when those Mars spacecraft turn their cameras toward this thing, we might finally get answers, or we might get something far more disturbing. If you're as fascinated by this as I am, hit that like button and subscribe. And tell me in the comments where you were listening from, what time it is there, and the weirdest thing that ever happened to you. Chapter 1. Avi's shocking 6 out of 10. Rating? Avi just did something that's sending shock waves through astronomy. The Harvard astrophysicist who claimed Oumuamua might be alien tech back in 2017 has now rated 3I Atlas at 6 out of 10 on his scale for potential technological origins. That's 60% confidence this isn't natural. And before you roll your eyes, understand what changed his mind. It wasn't speculation. It was data from the James Webb Space Telescope, the Very Large Telescope in Chile, and Hubble, all showing things that shouldn't exist. Webb observed 3I Atlas on August 6th and found its gas plume is 95% carbon dioxide and only 5% water. That's 16 times more extreme than any known comet at the distance from the Sun. Comets are supposed to be water-rich. This one isn't. Then the VT detected nickel in the gas plume. Strong, clear emission lines. But here's the kicker. No iron. None. In the entire history of observing space objects, nickel and iron always appear together. They're forged together in dying stars, expelled together in supernovas. Finding nickel without iron would be like finding smoke without fire. It doesn't happen in nature, but it happens all the time in industrial manufacturing. High purity nickel alloys, aerospace components. The signature matches factory production, not cosmic debris, and the nickel production is increasing. When first detected in July, the emission rate was modest. By August, it had exploded 25-fold. The closer it gets to the Sun, the more metal it's vaporizing. Loeb has faced brutal criticism for even suggesting extraterrestrial explanations. Penn State's Jason Wright called his work sloppy. NASA's Tom Statler said it looks like a comet and does comet things, but neither of them are explaining the nickel without iron. Neither are addressing the extreme CO2 ratio or the trajectory that has a 1 in 500 chance of being random. Lowe himself admits his technological hypothesis is largely an exercise. He says the most likely outcome is still a natural comet, but most likely isn't certain, and with a 6 out of 10 rating, he's saying there's a 40% chance we're wrong about everything. The October 3rd Mars flyby will tell us more. If the High-Re camera shows a nucleus larger than 5 kilometers, as his mass calculations suggest, then the natural explanation collapses. There isn't enough rocky material in interstellar space to deliver objects that large this frequently. Chapter 2. The amateur photo that broke the internet. Social media is exploding with something professional astronomers won't touch. Amateur astrophotographers are sharing images of 3E Atlas that don't look like a comet. Instead of the fuzzy diffuse glow you'd expect, some photos show structure, geometry, hard edges that shouldn't be there. Michael Jagger and Gerald Raymond, two highly respected amateur astronomers, captured 3 Atlas during the total lunar eclipse on September 7th from Namibia. The images showed the object glowing green with a bluish tinge, clearly gas-rich and visible in both blue and green filters. Professional astronomers acknowledge these images. They're legitimate. But it's the other amateurs, names that haven't made press releases, who captured what's now being called the structured images, photos circulating on Reddit, Twitter, and astronomy forums showing something more solid, more defined beneath the gas envelope, something that looks less like a diffuse cloud and more like an object with edges. The professional response silence, or immediate dismissal. When pressed, they cite motion blur, exposure artifacts, telescope tracking issues, all technically valid concerns when imaging fast-moving objects thousands of times fainter than naked eye visibility. Smearing and distortion are common problems. But here's what makes this fascinating. The Atlas Survey telescope that discovered 3 Atlas is only 20 in diameter. That's backyard astronomer size. High-end hobbyists have equivalent or better equipment, so when someone with similar gear captures unusual structure, why the automatic dismissal without investigation? On Reddit's astronomy subreddits, the debates are fierce. Users are comparing images side by side. Some show classic commentary appearance with developing coma and faint tail. Others show something harder to explain. Compact cores, irregular shapes, pixel patterns that don't match standard point spread functions for stars or comets. Half the commenters scream image processing errors. The other half demand someone with professional equipment replicate the observations to verify or falsify. That's not happening. Instead, professional astronomers jump into threads to discredit without offering to check themselves. One image circulating widely on X shows what appears to be a more compact, less diffuse core than Hubble captured. The amateur claimed it was taken with a 14-inch Schmidt Cassegrain telescope and stacked from 50 individual exposures. Standard practice for deep sky imaging. Professional astronomers immediately cited atmospheric distortion, tracking drift, chromatic aberration, anything to explain it away. But none of them suggested pointing larger scopes at the same coordinates. None offered to help verify the observation, just dismissal. Here's what makes this situation strange. The Hubble Space Telescope image from July 21st showed a teardrop-shaped cocoon of dust with the glow extending ahead of the object toward the Sun. That's official NASA data, and that already violated expectations. Comet tails are supposed to stream behind, pushed by solar wind and radiation pressure. This one was pointing forward. Professional astronomers called it interesting, puzzling, worth studying. When amateurs see weird stuff in that same time period, it's called user error. Then Gemini South captured images on August 27th, showing the first evidence of a proper anti-solar tail streaming behind the object. So, between July and August, something changed. Either 3 Atlas started behaving more like a traditional comet, or our viewing angle shifted enough to reveal what was always there. Most of the amateur photos claiming unusual structure were taken in that July to August window when the object was behaving least like a comet, when even professional observations showed anomalies. And here's another data point that doesn't get enough attention. NASA's Spherex Infrared Space Telescope observed 3 Atlas in early August and saw it as a point source. No extended coma, no tail, just a dot. That's not what comets look like in infrared. They show extended emission from warming gas and dust, but Spherex saw nothing of the sort, single bright point. So, we have a pattern. Professionals seeing anomalies they can't fully explain. Amateurs seeing anomalies that get dismissed as incompetence. Both photographing the same object during the same weird window when it wasn't acting like a comet. The European Space A's Mars Express and ExoMars Trace Gas Orbiter will photograph 3I Atlas on October 3rd using cameras designed to image the Martian surface from just hundreds of kilometers away. They'll be imaging this object from 30 million kilometers. ESA has already stated they don't expect spectacular images. It'll be less than a pixel in their cameras. But what if the amateurs were seeing something real? What if there is structure beneath the gas? The October observations might not resolve it either. We might need something closer, something with better instruments pointed directly at this thing without atmospheric interference. The truth is, we're flying partially blind. Professional telescopes have limited time and specific observation schedules. Amateurs have flexibility but less sophisticated equipment. And somewhere in that gap, something unusual is happening that neither side wants to fully acknowledge. Because if the amateurs are right, if there's structure that doesn't match natural comet morphology, then we're not talking about imaging artifacts. We're talking about rewriting what we thought we knew about interstellar visitors. Chapter 3, the October 3rd Mars Encounter. What they're not telling you. In 2 days, 3I Atlas passes within 29 million kilometers of Mars. That sounds like a safe distance. But here's what nobody's discussing. The minimum orbit intersection distance. The closest this thing gets to Mars' complete orbital path around the Sun is only 2.7 million kilometers. Avibi called this remarkable fine-tuning. When a Harvard physicist uses those specific words, you need to pay attention. The high-rise camera aboard the Mars Reconnaissance Orbiter will image 3I Atlas with a resolution of 30 kilometers per pixel on October 3rd. That's detailed enough to separate the nucleus from its surrounding dust cloud. Detailed enough to measure the actual surface area reflecting sunlight, and detailed enough to confirm whether this object is really 5 kilometers across like Lowe's latest mass calculations suggest. If it is that large, the natural comet explanation collapses entirely. Based on the limited reservoir of rocky material in interstellar space, we should have detected roughly 100,000 smaller interstellar objects on the scale of Oumuamua before finding something as massive as 3I Atlas. But we've only found 2 previous visitors. Both were tiny compared to this. But here's where things get genuinely disturbing. Lowe calculated that if 3-2 Atlas deployed a precursor probe, a smaller scout craft travelling ahead of the main object by approximately 30 million kilometers, that probe could intercept Mars on October 3rd or during the week preceding it. And here's the terrifying part. Earth-based telescopes cannot detect objects smaller than about 100 m at Mars distances. That's roughly the size limit of all spacecraft humanity has ever launched. Any precursor probe would be effectively invisible to us. The idea isn't as crazy as it sounds. If you were designing an interstellar mission to survey a planetary system, you wouldn't send one massive ship. You'd send a mothership with smaller reconnaissance probes, deploy them ahead to gather data on individual planets, while the main craft follows a safe trajectory through the system. It's exactly how we'd design such a mission if we had the technology. And the trajectory of 3I Atlas makes this disturbingly plausible. The object's path requires only a 10 to 15 km per s velocity adjustment during September, to reduce its closest approach distance to Mars to 0. For a technological object, that's a trivial maneuver. For a natural comet, it's impossible. The ejection speed of icy fragments from sublimating comets based on Webb telescope data is only about 0.4 kilometers per s, not nearly enough. NSA's Mars Express and ExoMars Trace gas orbiter will also observe 3I Atlas on October 3rd using multiple instruments: high-resolution cameras, spectrometers, particle sensors. They're designed to study the Martian surface and atmosphere, but they're being repurposed to study this visitor. The instruments will attempt to characterize the comet's volatile activity and composition from 30 million kilometers away. But there's a secondary objective nobody's advertising. HEROES won't just image 3E Atlas itself. It'll scan the surrounding space, looking for anything that might be travelling ahead of the main object, looking for precursor probes. Lowe suggested this explicitly in his blog posts. Use HiRISE to search for objects preceding 3 Atlas that get closer to Mars than the main body. If materials from 3 Atlas reach Mars in October, materials that couldn't possibly get there through natural sublimation and ejection, that would be a signature of technology. The timing is suspicious too. 3 Atlas reaches its closest approach to Mars exactly 1 week before it disappears behind the Sun from Earth's perspective. We get one good look with spacecraft at Mars and then the object vanishes into solar glare for 2 months. It won't be observable again until early December. If you wanted to deliver something to Mars undetected, this would be the perfect window. Deploy your probe during the October 3rd flyby, while Earth's telescopes watch the main object. Then the mothership hides behind the Sun for 8 weeks while the probe does whatever it came to do. NASA's Curiosity and Perseverance rovers on Mars' surface might attempt observations as well. Though the comet will be incredibly faint from the surface perspective, the Mars Reconnaissance Orbiter is really our best shot at detailed imaging. And then there's the question of what happens if they find something. If HIRS captures an image showing multiple objects or unusual maneuvering or anything that suggests artificial activity, what's the protocol? Do they announce immediately? Do they verify through additional observations? Do they classify it? There's no established procedure for this scenario because nobody seriously planned for it. The protocols for detecting extraterrestrial intelligence focus on radio signals or optical beacons, not physical craft passing through the inner solar system. In 24 hours, we'll know if the amateur astronomers were seeing something real. We'll know if the nickel without iron signature means what LOE thinks it means. We'll know if that too. 7 million kilometers minimum orbit intersection distance was coincidence or design, or we'll see a perfectly normal comet nucleus consistent with natural formation and all the speculation will collapse into embarrassment. But either way, October 3rd, 2025 is a date that might end up in history books. The day we either confirmed 3 Atlas as an exotic but natural interstellar comet, or the day everything changed. Chapter 4. The Nickel Without Iron Bombshell. The Very Large Telescope in Chile just detected something that shouldn't exist in nature. Between late July and late August 2025, spectroscopic observations revealed neutral nickel atoms streaming from 3I Atlas, strong emission lines at multiple wavelengths, clear, unambiguous signatures of nickel sublimating from the object's surface as it approaches the Sun. But there was no iron, not a trace. 0 emission lines in any of the expected wavelengths where iron should appear. Let me explain why this is absolutely shocking. Nickel and iron are cosmic twins. They are forged together in the same nuclear reactions inside massive stars. When these stars explode as supernovas, nickel and iron are expelled together into space. They condense into dust grains together. They get incorporated into asteroids and comets together. In every single space rock humanity has ever analysed, Whether meteorites that fell to Earth or samples returned from missions, nickel and iron appear in predictable ratios. Finding one without the other would be like finding hydrogen without protons. It violates the fundamental chemistry of how the universe works. The VT team, led by researchers who have no connection to Avi's more controversial claims, published their findings with carefully worded conclusions. They suggested the nickel might come from nickel carbonyl compounds, molecules that could theoretically exist in extremely cold interstellar environments. These compounds are volatile, breaking apart when exposed to ultraviolet light to release nickel and carbon monoxide. But even the VT team admitted this would be unprecedented, never observed in any solar system comet, never detected in interstellar space. A purely theoretical explanation for an observation that demands one. Here's what makes it worse. The nickel production isn't stable. When 3-2 Atlas was first observed at 3.9 astronomical units from the Sun in July, the nickel emission rate was around 10 to the 21st. Significant, but not alarming. By late August, at 2.85 astronomical units, that rate had increased 25-fold. 25 times more nickel streaming off the surface in just 1 month. The closer this object gets to the Sun, the more dramatically its metal emission increases, and that increase doesn't follow the gradual curves we see with normal cometary outgassing. It's exponential, steep, like something is being systematically vaporized by increase in heat. Avi pointed out what nobody else wanted to say explicitly. On Earth, we separate nickel from iron routinely in industrial processes. High-purity nickel is used in specialized alloys for aerospace applications, electronics, batteries, anything requiring specific thermal or electromagnetic properties. The signature we're detecting from 3 Atlas matches industrial nickel production, not natural cosmic abundances. Critics immediately jumped on this. They said Lowe was cherry-picking data, seeing what he wanted to see, engaging in motivated reasoning. Penn State's Jason Wright was particularly harsh, calling the comparison to industrial processes misleading and unscientific. But here's what the critics aren't addressing. If the nickel is coming from natural carbonyl compounds, where's the iron-iron forms similar volatile compounds? Iron pentacarbonyl is well studied in chemistry. If the conditions existed to create and preserve nickel carbonyl through billions of years in interstellar space, those same conditions would create iron carbonyls. They should both be there. But only nickel is showing up. The VT observations also detected rapidly rising cyanide production, hydrogen, cyanide, and related compounds appearing in the gas plume around 3E Atlas, at rates that increased steeply as the object approached the Sun. Lowe suggested the colour change from red to green that amateur astronomers observed might be connected to this cyanide spike. Cyanide itself isn't unusual in comets. It's a common carbon and nitrogen compound found in many icy bodies. But the rate of increase, the steep production curve matching the nickel emission, suggests these processes are linked somehow. What's really fascinating is what this tells us about the object's composition. If most of the mass is in the form of carbon dioxide ice with trace amounts of water as Webb discovered, and if the surface is outgassing nickel and cyanide at increasing rates, then we're looking at chemistry that doesn't match anything formed in our solar system. Comets from the Oort cloud or Kuiper belt are water-rich because they formed in a region where water ice was stable. The ratio of water to carbon dioxide reflects the temperature and composition of the protoplanetary disk where they originated. 3I Atlas has the reverse ratio. It's CO2 dominant with minimal water. That suggests it formed in a very different environment around a very different star. Or it suggests it's not natural at all. There's a third possibility nobody wants to discuss seriously. What if 3E Atlas is natural in origin? an ancient comet from another star system, but it's been travelling through interstellar space for so long that its surface chemistry has been altered cosmic rays, impacts with interstellar dust grains, chemical reactions in the near absolute zero void. 7 billion years of exposure could do strange things to surface composition. Maybe the nickel without iron signature is real, but the explanation is somewhere between natural comet and artificial craft, something we haven't thought of yet because we've never studied an object this old from this far away. The October observations will help when HIRIS images 3-2 Atlas from Mars orbit. Spectroscopic data from Mars Express and ExoMars Trace Gas Orbiter will capture additional emission lines, more data on the nickel production, more measurements of the cyanide and carbon dioxide outgassing, more constraints on what this thing actually is. But right now, with the data we have, 3I Atlas is releasing industrial-grade nickel into space while showing no iron whatsoever, and nobody has a satisfying natural explanation for that. Chapter 5. The Disappearing Act Hidden Behind the Sun. In late September, 3I Atlas vanishes. Not destroyed, not deflected, just hidden. It passes too close to the Sun from Earth perspective to observe. For 2 months from late September through November, ground-based telescopes lose line of sight completely. The object disappears into solar glare. And here's what makes this timing so suspicious. 3 Atlas reaches perihelion, its closest approach to the Sun, on October 30th, 2025. That's the moment when comets are most active, when solar heating drives maximum outgassing, when their behavior reveals the most about their composition and structure, the single most important observation window for understanding what this thing actually is, and we can't see it. Earth will be on the opposite side of the Sun. Avi suggested this could be intentional, not random orbital mechanics, but deliberate positioning. If 3 Atlas wanted to avoid detailed observation from Earth-based telescopes during its brightest, most active phase, this trajectory accomplishes exactly that. It hides behind 150 million kilometers of incandescent plasma at the critical moment. NASA and other space agencies are trying to work around this. The Parker Solar Probe, currently in close solar orbit studying the Sun's corona, might catch a glimpse if the timing aligns. The Solar and Heliospheric Observatory, SOHO, which stares at the Sun continuously to watch for coronal mass ejections, will have 3I Atlas pass through its field of view. But SOHO's cameras are designed for solar observation, not faint comets. The object will likely be too dim against the Sun's overwhelming brightness. Jupiter icy moons. Explorer JUICE is currently on the far side of the Sun relative to Earth. It's using its high-gain antenna as a heat shield, which means limited data transmission. JUICE will attempt observations of 3I Atlas in November using cameras and spectrometers, but we won't receive that data until February 2026, months after the fact. So, we're effectively blind during the most critical period. October 30th happens behind a stellar curtain, and what could happen during these 2 months if 3 Atlas is natural? Nothing unexpected. It heats up, outgasses more intensely, possibly fragments if thermal stress cracks the nucleus, and emerges in December slightly smaller and less active as it heads back toward interstellar space. But if it's not natural, if there's any technological component whatsoever, those 2 months are the perfect window for activity we're not supposed to see. Orbital corrections, probe deployments, trajectory adjustments. Anything requiring propulsion or maneuvering that would be obvious to Earth-based observers if we could see it. Low calculated that a velocity change of just 10 to 15 kilometers per s during September or October could alter 3 Atlas's trajectory significantly, enough to deliver payloads to Mars, Venus, or even Earth. For a natural comet, that's impossible. Sublimating ice produces velocity kicks of maybe half a kilometers at most. But for something with an engine, it's trivial. The other possibility is more unsettling. What if the disappearing act is exactly that? What if 3IA Atlas doesn't emerge in December? What if it uses the perihelion passage to shed velocity, fall into a long elliptical orbit around the Sun, and become a permanent resident of the inner solar system? We'd have no way of knowing until December when it's supposed to reappear. And if it doesn't show up where calculations predict, if the orbit has changed substantially, that would be a signature of propulsion, of technology, of intent. There's precedent for this kind of thinking, though not from interstellar objects. In 1986, the Soviet Vega probes flew past Hall's comet and detected something unexpected. The nucleus was far darker than predicted, reflecting only 4% of incident sunlight. Before Vega, scientists assumed comets were bright, icy objects. Turned out they were incredibly dark, covered in organic compounds and dust. The ice is buried beneath a crusty surface layer. That discovery changed our understanding of what comets look like up close. And it happened because we sent spacecraft to look. Remote observation from Earth had given us completely wrong assumptions. With 3I Atlas, we're back to remote observation during the critical period, inferring behavior from limited data, making assumptions that could be completely wrong. And we won't know until December 3rd when it emerges from behind the Sun and becomes visible again to ground-based telescopes. Amateur astronomers are already preparing. Telescopes around the world are being scheduled for early December observations. Everyone wants to be first to spot it coming back. Everyone wants to see if it looks different, if its activity level changed, if the trajectory matches predictions. Because if it doesn't match, if 3E Atlas comes out of perihelion on a different path or with different characteristics, that's when the mainstream astronomical community will have to take the artificial hypothesis seriously, not as a fringe theory from one controversial scientist, but as a legitimate possibility requiring investigation. The Disappearing Act also means we miss potential fragmentation events. Natural comets sometimes break apart near perihelion. Thermal stress fractures the nucleus. Internal pressure from trapped volatiles blows chunks off the surface. We've watched it happen with several comets that ventured too close to the Sun. If 3E Atlas fragments, we won't see it happen. We'll only see the aftermath in December. Multiple pieces instead of one. Debris trails, changed rotation, and fragmentation would actually support the natural comet hypothesis. Technological objects don't typically split apart from solar heating, unless the fragmentation is controlled, unless what we interpret as breakup is actually deployment, multiple smaller objects separating from the main body, each heading toward different targets in the inner solar system. That scenario sounds like science fiction, but so does nickel without iron, so does the perfect ecliptic alignment. So does the Mars flyby with 2.7 million kilometers precision. Every piece of data we collect makes the science fiction scenarios slightly less fictional. The December emergence will tell us something. Maybe not everything, but something. And until then, we wait in the dark, hoping the object that comes back is the same one that went behind the Sun. Chapter 6. The anomalously massive object 33 billion tons. A new paper just dropped that's making astronomers very uncomfortable. Richard Chloe, Peters Veed and Avi Lowe analysed 4022 observations of 3I Atlas from 227 observatories worldwide between May 15th and September 23rd. They tracked the object's position with incredible precision, comparing its actual trajectory to what gravity alone would predict. And they found something shocking. 3I Atlas shows almost no non-gravitational acceleration, despite massive outgassing detected by Webb and other telescopes, despite losing hundreds of kg of material per second. The object's trajectory deviates less than 15 km per day squared from a pure gravity-based path. That means it's incredibly massive, far more massive than its brightness would suggest. The math is straightforward. When a comet outgasses, the expelled material acts like a tiny rocket engine. It pushes the comet slightly off course. The amount of deviation depends on how much mass you're expelling and how massive the comet is. Small comets with active outgassing show significant non-gravitational acceleration. Large comets with the same outgassing show less. 3I Atlas is expelling massive amounts of gas. Webb measured 129 kg/second of carbon dioxide, 6.6 kilograms per S of water, 14 kg/second of carbon monoxide. That's substantial. That should produce noticeable trajectory changes. But it doesn't. The deviation is below detection limits, which means the object's mass must be enormous to resist that rocket effect. The calculations put the lower limit at 33 billion tons, 33 trillion kilograms with a nucleus diameter of at least 5 kilometers. That makes 3I Atlas 3 to 5 orders of magnitude more massive than the previous two interstellar objects. Oumuamua was maybe hundreds of meters across at most. Boris was perhaps a kilometer. This thing is 5 times larger in diameter, which translates to over 100 times more volume and mass. And here's the problem. Based on what we know about interstellar space, based on surveys of how much rocky and icy material exists between stars, objects this large should be incredibly rare. So rare that we should detect roughly 100,000 smaller interstellar visitors before finding one as massive as 3I Atlas. But we've only found 2. Just 2 previous interstellar objects in all of human history. It's like winning the lottery 3 times in a row. Statistically possible, but so improbable that you start questioning whether the game is rigged. Lowe argues this points toward a non-random trajectory. If 3 Atlas was deliberately sent to the inner solar system, if its path was chosen rather than random, then the statistical problem disappears. We're not randomly sampling the interstellar population. We're being visited by something specific. Critics say this is ridiculous. They point out that our detection capabilities have improved dramatically in recent years. The Atlas survey that found 3 Atlas only became fully operational in the last decade. Before that, we simply weren't looking hard enough. Of course, we're finding more interstellar objects now. We finally have telescopes capable of spotting them. That's a fair point. The Vera Rubin Observatory, which came online in 2025, found over 2000 asteroids in its first 10 hours of operation. Our ability to detect faint, fast-moving objects has exploded. Maybe we'll find dozens more interstellar visitors in the next few years and the statistical problem will resolve itself. But it doesn't explain the mass. Even with better detection, even if we find more interstellar objects, the size distribution should follow predictions. Lots of small objects, fewer medium ones, very few large ones. That's how populations work everywhere else in astronomy. Small asteroids outnumber large ones by millions to 1. 3 Atlas breaks that pattern. It's the largest we've found by far discovered before we've catalogued the thousands of smaller ones that should be more common. The lack of non-gravitational acceleration also rules out certain explanations. Some scientists suggested 3 Atlas might be a loosely bound rubble pile barely held together by weak gravity. If that were true, outgassing would blow it apart. The rocket forces would overcome the gravitational binding and the object would fragment. But it's not fragmenting, it's holding together despite substantial mass loss. That requires either a solid, coherent nucleus or something binding it together more effectively than self-gravity. The October 3rd Mars observations might resolve the size question. If HIRIS can separate the nucleus from its dust cloud and measure how much light is actually reflecting from solid surface versus scattered by surrounding particles, we'll get a better estimate of the true nucleus diameter. If it's larger than 5 kilometers, the natural explanation becomes untenable. There's one other possibility that hasn't gotten much attention. What if 3 Atlas is surrounded by a large diffuse cloud of very fine dust, and most of the brightness we're seeing comes from that dust rather than from the nucleus itself in that case? The nucleus could be much smaller and the mass calculations would be wrong. But Webb and Spherex observed in infrared. Infrared sees through dust to reveal solid surfaces underneath. Spherex saw 3I Atlas as a point source, not an extended cloud. That suggests there isn't a huge dust envelope obscuring a small nucleus. What we're seeing is mostly the object itself. So, we're back to a 5 kilometers nucleus with at least 33 billion tons of mass, showing almost no non-gravitational acceleration despite massive outgassing. An object that statistically shouldn't exist. Arriving on a trajectory with 1 in 500 odds of Ben random, the data keeps piling up. Each observation makes the natural explanation slightly less convincing. Not impossible, but increasingly contrived, requiring more and more special pleading, more coincidences, more unprecedented conditions. Chapter 7. Chemical Impossibilities. The 95% co-mystery. The James Webb Space Telescope observed 3I Atlas on August 6, 2025 using its near-infrared spectrograph. What it found rewrites our understanding of what interstellar comets should look like. The gas plume surrounding 3I Atlas consists of 95% carbon dioxide and only 5% water. That's 16 times more extreme than expected for a typical comet at that distance from the Sun. Every comet we've ever studied from our solar system is water-rich. They formed in the cold outer regions where water ice was the dominant volatile. Carbon dioxide is there too, but in much smaller amounts. The ratio reflects the temperature and chemistry of the proto-planetary disk where they originated. 3I Atlas has the reverse chemistry. It's a dry ice ball with barely any water, and that tells us it formed somewhere very different around a star with different composition in a disk with different temperatures and pressures in an environment nothing like our solar system's formation conditions. Martin Cordner, the principal investigator for the Webb observations, stated, "This is among the highest carbon dioxide to water ratios ever measured in any comet. Not just unusual, unprecedented." But the chemistry gets stranger. Webb also detected carbon monoxide and carbonyl sulfide in significant quantities. The combination of these compounds suggests the object formed in an extremely cold environment, potentially colder than the outer reaches of our solar system. Some researchers believe 3I Atlas might have originated in a molecular cloud region, or been ejected from a planetary system much farther from its star than our Kuiper belt. Then there's the colour change that amateur astronomers documented. In July and early August, observations showed 3I Atlas had a reddish coma. That colour typically indicates organic compounds, complex carbon molecules that absorb blue light and reflect red, standard stuff for comets. But on September 7th, during the total lunar eclipse, Michael Jagger and Gerald Raymond photographed it glowing bright green with a bluish tinge. The transformation happened seemingly overnight. Green comets are well known. The colour comes from diatomic carbon molecules in the coma, absorbing ultraviolet sunlight and emitting green light. Except 3I Atlas was already analysed in August by astronomers at Kitt Peak Observatory. They found it was among the most carbon chain-depleted comets known. It had very low concentrations of diatomic carbon, the exact molecule that creates green comets. So how does a comet with almost no diatomic carbon suddenly glow bright green? Avibi suggested the colour change might be connected to the rapid increase in cyanide production detected by the Very Large Telescope. Cyanide compounds can also produce greenish colours under certain conditions. But that raises another question. Why is cyanide production increasing so dramatically? The VT observations showed hydrogen cyanide emission rising steeply as 3 Atlas approached the Sun. The production rate wasn't gradual like normal cometary outgassing. It was exponential, like something was being thermally processed at accelerating rates. Stephanie Millam from NASA's Goddard Space Flight Center, who worked on the Webb observations, suggested 3I Atlas might have a cooked shell. Billions of years travelling through interstellar space exposed to cosmic rays and stellar radiation could have chemically altered its surface layers. Carbon dioxide might have been created or concentrated through these processes, giving it unusual surface chemistry. That's plausible. We've never studied an object this old. 7 billion years is older than our entire solar system. Who knows what happens to ice over that timescale in the near absolute zero void between stars? But it doesn't explain everything. The nickel without iron signature isn't explained by surface processing. Neither is the lack of non-gravitational acceleration. Despite massive outgassing, each anomaly might have a natural explanation individually. Together, they form a pattern that's increasingly difficult to dismiss. There's also the Spherex observation that showed 3I Atlas as a point source with no extended emission. Infrared telescopes see through dust reveal the thermal emission from warming ice and rock. Spherex should have seen a large diffuse glow from carbon dioxide ice sublimating across the surface. Instead, it saw a dot, a concentrated point of infrared emission consistent with a relatively compact solid object. That observation contradicts the comet model, or it suggests the object has very unusual thermal properties. Perhaps the surface is highly reflective, bouncing sunlight away before it can heat the interior. Perhaps there's an insulating layer preventing heat penetration. Perhaps the nucleus is spinning so rapidly that thermal energy distributes before causing significant sublimation. Or perhaps it's not outgassing the way we think it is. Perhaps what we're interpreting as sublimation is something else entirely. The chemical data also reveals information about where 3E Atlas might have originated. The low metallicity, the high hydrogen and ice content suggests it came from a region of the galaxy where star formation happened early. The thick disk of the Milky Way, populated by older stars with less heavy element enrichment. Models place its origin somewhere between 7 and 11 billion years ago, making it a relic from an epoch when our galaxy was very different. If 3 Atlas is natural, it's a time capsule from the ancient galaxy. A chunk of primordial ice carrying chemical signatures from billions of years before Earth existed. That alone would make it the most scientifically valuable object we've ever observed. But the chemistry keeps not quite fitting. The carbon dioxide dominance is explainable. The lack of water is explainable. The cyanide is explainable. The color change is explainable. Each piece has a potential natural explanation that requires stretching our models slightly but not breaking them. It's the combination that's troubling. It's the pattern of anomalies all appearing in the same object. It's the statistical improbability of this specific set of characteristics occurring together by chance. November and December will bring more data. When 3I Atlas emerges from behind the Sun, ground-based telescopes will capture fresh spectra, more emission lines, more chemical signatures, more constraints on composition, and by comparing Preparian chemistry to post-Parian chemistry, we'll learn whether the solar heating changed anything fundamental about this object's behaviour. Chapter 8, The Anti-Tail That Shouldn't Exist. The Hubble Space Telescope captured the highest resolution image of 3 Atlas on July 21st, 2025. What it showed violated basic comet physics. The image revealed a teardrop-shaped cocoon of dust, but the glow was elongated ahead of the object toward the Sun. There was no distinct tail streaming behind it in the anti-Euler direction. That's backward. Comet tails are pushed away from the Sun by solar wind and radiation pressure. The tail should always point away from the Sun, creating the classic swept-back appearance we associate with comets. But 3 Atlas had its bright side facing forward toward the Sun, with no obvious tail behind it. Jav Loeb and his colleague Eric Kaito published the only paper in scientific literature attempting to explain this anti-tail. They suggested the forward glow might be dust particles being pushed ahead of the nucleus by some internal process, but even they admitted this was speculative. There's no clear mechanism that would create a forward-pointing dust cloud on a natural comet. Other astronomers dismiss the observation entirely. They claimed the glow wasn't an anti-tail at all, just smearing from Hubble's tracking of the fast-moving object. The telescope was following 3I Atlas as it moved through space, which caused background stars to streak in the exposure. Maybe the forward glow was an artifact of that tracking motion. But Hubble's image processing teams know how to account for tracking effects. The strias are obvious in the image. The forward glow is not a streak, is a distinct region of enhanced brightness with defined structure. If it was just a tracking artifact, it should look like the stellar trails. It doesn't. Then, in late August, the Gemini South Telescope captured new images using its multi-object spectrograph. And suddenly, 3 Atlas had developed a proper tail, a weak teardrop-shaped tail in the anti-direction behind the object, exactly where comet tails are supposed to be. So between July 21st and August 27th, something changed. Either the object started behaving like a normal comet, or our viewing geometry shifted enough to reveal what was always there but obscured by the dust cloud. The July Hubble image was taken when 3I Atlas was at about 4 astronomical units from the Sun. The August Gemini image was at roughly 2.6 astronomical units. Closer to the Sun means more solar heating, more outgassing, potentially more dust production. It's plausible that the tail simply hadn't developed yet in July and appeared later as activity increased. But that doesn't explain the forward glow. Normal comets don't have bright halos pointing toward the Sun. They have comas, spherical clouds of gas and dust surrounding the nucleus. The coma can be brighter on the sunward side because that's where sublimation is most active. But it shouldn't create a directional glow ahead of the object's motion. There's another detail in the Hubble image that's puzzling. The dust cocoon extends about 3000 K on all sides of 3I Atlas. Low calculated that if the nucleus is 10 kilometers in diameter, the dust density at 3000 km out would be diluted by a factor of 90,000 compared to its density near the surface. That's a huge drop-off for that diluted dust to still be bright enough for Hubble to detect. Either there's an enormous amount of dust being produced, or the dust particles are exceptionally reflective, or something about the scattering geometry is unusual. The Gemini images also showed colour variations. Different wavelength filters revealed different structures. In ultraviolet, the object appeared more compact. In red and infrared, the dust cloud is more extended. That's consistent with normal dust scattering properties where smaller dust particles scatter blue light more efficiently and larger particles scatter red light. But it also means the dust grain size distribution is not uniform. There's a population of very small particles close to the nucleus and larger particles farther out. That distribution pattern could tell us about how the dust is being ejected. Fast-moving small particles, slower-moving large particles, classic cometary behavior, except the rotation period complicates things. Observations showed 3I Atlas rotating once every 16 hours. That's relatively slow for a small object. A 10 kilometers nucleus rotating every 16 hours has a surface velocity of only about 1 m/s at the equator. That's not fast enough to fling dust particles into space through centrifugal force. So the dust must be ejected by gas pressure from sublimation. Carbon dioxide subliming from the sunward side carries dust grains with it. But the analysis of the Hubble image suggested dust particles were moving at about 20 m/s. That's much faster than the rotation speed, but consistent with gas drag from sublimation. Here's where it gets interesting. If dust is being ejected at 20 m/s by carbon dioxide outgassing, and if the object is losing 129 kg/s of carbon dioxide as Webb measured, then the dust production rate should be substantial, probably tons. That much dust should create a very obvious tail, a bright extended tail visible in professional telescope images. But the July Hubble image didn't show one, only the forward glow and a diffuse coma. One possibility is that the dust particles are so small they're being pushed forward by radiation pressure before they can form a traditional tail. Radiation pressure from sunlight can accelerate tiny dust grains faster than gravity pulls them toward the sun. If the dust grain size is less than a micron, radiation pressure dominates and the particles could be pushed ahead of the nucleus. But that would create a forward tail, not a forward glow. The morphology is wrong. Another possibility is that the dust is being electrically charged by solar ultraviolet radiation and interacting with the sun's magnetic field. Charged dust behaves differently than neutral dust. It can be focused or dispersed by magnetic fields in ways that create unusual shapes. NASA's Sphere-X observation adds to the confusion. It saw 3E Atlas as a point source in infrared with no extended emission. No coma, no tail, just a dot. But Hubble clearly saw extended structure. The difference is wavelength. Hubble observed invisible light. Sphere-X in infrared. Dust reflects visible light but emits thermal infrared based on temperature. If the dust around 3I Atlas is very cold, colder than expected for that distance from the sun, it would be dim in infrared, even if bright invisible light. That suggests the dust isn't being efficiently heated by sunlight. Maybe it's highly reflective, bouncing light away before absorbing heat. Maybe it's composed of materials with unusual thermal properties. The tail situation will become clearer in December when 3I Atlas emerges from behind the sun. Fresh observations from multiple telescopes at multiple wavelengths will show whether the tail developed further, whether it matches normal cometary tails, or whether it's still showing unusual characteristics that don't fit the models. Chapter 9. The 1 in 500 Trajectory Coincidence. 3I Atlas is travelling on a retrograde orbit inclined at roughly 175 degrees to the ecliptic plane. That sounds extreme, but here's what it actually means. The object is moving almost exactly in the plane of the planets, just backward. It's threading through the solar system along the same flat disk where Earth, Mars, Venus, and Jupiter orbit, but in the opposite direction. The probability of that happening randomly, 1 in 500. Most objects entering the solar system from interstellar space should come from random directions. Space is three-dimensional. There's no preferred orientation. If interstellar comets are just debris ejected from other star systems on random trajectories, they should arrive from all angles. Some from above the ecliptic plane, some from below, some from the sides, uniformly distributed across the celestial sphere. But 3I Atlas came in almost perfectly aligned with the planetary orbits, just 5 degrees off from the ecliptic plane. That's not impossible, but it's highly improbable. And it's not just the inclination. The trajectory brings 3I Atlas close to multiple planets. It passes within 30 million kilometers of Mars on October 3rd. It will pass within reasonable proximity to Venus. And in March 2026, it approaches within 54 million kilometers of Jupiter. Each individual close approach isn't remarkable. Space is big. Lots of orbits pass near planets without being deliberately aimed. But the combination, the alignment with the ecliptic plus multiple planetary encounters, reduces the probability significantly. Lowe calculated that the combined odds of all these geometric factors occurring by chance is roughly 1 in 500. Not impossible, but suspicious enough to warrant consideration of non-random explanations. If 3I Atlas was deliberately sent to survey the inner solar system, you'd want a trajectory that passes near the major planets. You'd want to align with the ecliptic plane because that's where interesting stuff is happening. All the rocky planets, most of the moons, the asteroid belt, the regions where life could potentially exist. A surveyor probe would naturally follow this geometry. Critics argue this is selection bias. We're only noticing 3 Atlas because it came close enough to detect. There might be hundreds of interstellar objects passing through the outer solar system on random trajectories that we never see because they're too far away and too faint. The ones we detect are necessarily the ones that came close to the Sun and Earth. That's valid. Our detection capability is heavily biased toward objects that pass through the inner solar system where our telescopes are concentrated. We might be missing the vast majority of interstellar visitors that stay in the outer regions, but it doesn't explain the specific alignment. Even among objects that pass close to the Sun, most wouldn't be aligned with the ecliptic. Most would have high inclinations diving through the planetary plane at steep angles. The fact that 3 Atlas is nearly coplanar with the planets is unusual even within the subset we'd be capable of detecting. There's another aspect of the trajectory that's interesting. 3I Atlas is on a hyperbolic orbit with an eccentricity of about 6.16. That means it's moving well above escape velocity. Is not gravitationally bound to the Sun. It came from interstellar space and it's returning to interstellar space. But the trajectory can be traced backward by running the orbital mechanics in reverse. Astronomers can calculate where 3E Atlas came from originally. The calculations suggest it originated somewhere in the thick disk region of the Milky Way, possibly from a star system 7 to 11 billion years old. That's incredibly ancient. Older than our Sun, older than our solar system. If 3E Atlas formed around a star that old, it's been travelling through space for potentially billions of years. The cosmic radiation exposure, the chemical alterations, the sheer age of the object makes it unlike anything we've studied before. The path through the galaxy also tells us something. At its current velocity minus the gravitational acceleration from the Sun, 3I Atlas was travelling at about 58 km per s through interstellar space before entering our system. That's typical for objects in the thick disk population. The velocity matches expectations. What doesn't match is the arrival timing. 3 Atlas entered the inner solar system in mid-2025 just as our detection capabilities reached the point where we could spot it. The Vera Rubin Observatory came online. Atlas reached full operational status. Spherex launched. All the infrastructure needed to characterize an interstellar visitor was in place. Is that coincidence, or is it timing? If an advanced civilization wanted to send a probe to survey our system, they might choose their arrival time strategically. Wait until the target civilization has developed enough technology to detect and study the probe. Arrive when telescopes exist that can characterize composition and measure trajectories. Make first contact when the recipients are capable of understanding what they're seeing. That sounds like science fiction, but it's not impossible. Any civilization capable of interstellar travel would likely be capable of observing target systems from a distance. They could watch for technological signatures, radio transmissions, artificial lighting, atmospheric pollution, signs that a civilization has reached a certain development threshold. Earth has been broadcasting radio signals for over a century. Our technology signatures have been visible to external observers for decades. If 3I Atlas was sent in response to detecting those signatures, the timing would make sense. Of course, this requires accepting that interstellar travel is feasible, that some civilization figured out how to send objects across light years of space, that they chose to send one here, that they disguised it as a comet. That's a lot of assumptions. But the trajectory remains 1 in 500 odds, perfectly aligned with the planetary plane. Close approaches to multiple worlds arriving exactly when we develop the capability to study it properly. The March 2026 encounter with Jupiter will be telling if 3 Atlas maintains its predicted trajectory. Passing Jupiter at the expected distance with no deviations. That supports the natural explanation. Orbits governed purely by gravity are predictable. No surprises, but if there are deviations, If the trajectory changes in ways that can't be explained by gravitational perturbations from the planets, then we have a problem. Then we need to explain what altered the course, and natural explanations run out quickly once you eliminate gravity and outgassing. Chapter 10. What happens next? The verdict approaches October 3rd, 2025. That's tomorrow. The HiRISC camera aboard the Mars Reconnaissance Orbiter will point toward 3 Atlas as it passes 29 million kilometers away, 30 kilometers per pixel resolution, detailed enough to separate the nucleus from its dust cloud, detailed enough to measure surface area and constrain the actual size of this thing. If the nucleus is confirmed at 5 kilometers or larger, the statistical problem becomes impossible to ignore. We should have found thousands of smaller interstellar objects before detecting one this massive. The natural explanation requires increasingly contrived coincidences. ESA's Mars Express and ExoMars Trace Gas Orbiter will observe simultaneously using spectrometers and cameras, multiple wavelengths, multiple instruments, multiple perspectives. Between all the Mars spacecraft, we'll get the most detailed look at an interstellar object ever captured by humanity, and we'll search for precursor probes, objects travelling ahead of 3 Atlas that could reach Mars while we're watching the main body. HiRISC will scan the surrounding space. If anything shows up that shouldn't be there, if multiple objects appear instead of one, the conversation changes immediately. Then comes the waiting period. 3 Atlas disappears behind the Sun from Earth's perspective in late September. We lose line of sight. The object reaches perihelion on October 30th, its closest approach to the Sun, hidden from our telescopes by 150 million kilometers of incandescent plasma. 2 months of blindness. 2 months where anything could happen and we wouldn't see it. Trajectory adjustments, probe deployments, fragmentation. Whatever occurs during that window, we'll only learn about it in December when the object emerges. December 3rd is when ground-based telescopes expect to reacquire 3 Atlas. Amateur astronomers around the world are preparing. Professional observatories are scheduling time. Everyone wants first light on the object coming back from perihelion. And everyone will be comparing the post-perihelion observations to Preparian data. Has the brightness changed? Has the outgassing increased or decreased? Most importantly, is it where calculations predict it should be? If 3 Atlas emerges on a different trajectory, if its orbit has changed in ways that can't be explained by gravitational interactions with the Sun and planets, that's evidence of propulsion. That's evidence of technology. That's when even the skeptics will have to consider alternatives. The chemistry will tell us more. 2. Fresh spectroscopy in December will show whether the nickel without iron signature persists, whether the carbon dioxide dominance continues, whether new emission lines appear that weren't present before perihelion. Thermal processing from solar heating might alter surface chemistry in detectable ways if the object fragments that actually supports the natural comet hypothesis. Natural comets sometimes break apart near perihelion from thermal stress. We've watched it happen with comets like Shoemaker-Levy 9 before it impacted Jupiter. Fragmentation would be normal unless the fragmentation looks controlled, unless multiple pieces separate cleanly and head toward different destinations. Then fragmentation becomes deployment. March 2026 brings the Jupiter encounter. NASA's Juno spacecraft, currently in polar orbit around Jupiter, could potentially observe 3 Atlas as it passes within 54 million kilometers. Juno has cameras, spectrometers, particle detectors, instruments designed to study Jupiter, but capable of characterizing this visitor. There's been discussion about whether Juno could maneuver for a closer look. The spacecraft has limited fuel and a planned end of mission. Using that fuel to chase an interstellar object instead of studying Jupiter would be controversial. But if the October and December observations reveal something truly anomalous, the scientific case for redirecting Juno becomes compelling. ESA's JUICE spacecraft will also attempt observations in November, though we won't receive that data until February 2026 due to communication delays. JUICE is farther from Earth on the opposite side of the Sun, using its antenna as a heat shield. Data transmission is limited until it adjusts orientation. So, we're collecting observations across multiple months from multiple spacecraft at multiple locations in the solar system. By spring 2026, we'll have the most comprehensive dataset ever assembled for an interstellar object. And that dataset will either confirm 3I Atlas as an exotic but natural comet from another star system, or it will force us to seriously consider that we're being visited. The scientific community is preparing for both possibilities. Privately, astronomers are discussing what the protocols would be if technological signatures are confirmed. Who announces it? How do you verify extraordinary claims before going public? What are the implications for planetary defense if more objects follow? There's no established procedure because nobody seriously expected this scenario. SETI protocols focus on radio signals and intentional beacons, not physical objects masquerading as comets. The closest analogue is the procedures for announcing discovery of life on Mars or Europa: careful verification, peer review, multiple independent confirmations before any public statement. But those procedures assume months or years of analysis time. 3 Atlas is moving through and leaving the solar system. If we're going to study it properly, decisions need to happen quickly. Some scientists are advocating for an intercept mission. Launch a small probe to rendezvous with 3 Atlas before it escapes beyond the orbit of Jupiter. Get high-resolution images, sample the outgassing plume, measure magnetic fields and particle emissions up close. The problem is timing. Even a fast spacecraft would take months to catch up. By the time authorization and funding came through, by the time the probe was built and launched, 3 Atlas would be long gone. Interstellar objects move fast. Opportunities are measured in weeks, not years. That's what makes this October to March window so critical. This is our chance. Our only chance to gather data on the 3rd confirmed interstellar visitor before it vanishes back into the void between stars. After March, it'll be too far away and too faint for detailed observations. We'll watch it fade into the distance, extract every bit of information possible from the observations we managed to collect, and then wait. Wait to see if our analysis reveals natural explanations for all the anomalies. Wait to see if more interstellar objects arrive with similar characteristics. Wait to see if the statistical problem resolves or compounds. And we'll wonder, even if the data ultimately supports a natural origin, even if every anomaly finds a conventional explanation. We'll wonder because 60% probability of technology means 40% probability of natural and 40% isn't zero. The universe has surprised us before. Black holes, dark energy, exoplanets, gravitational waves. Each discovery revealed phenomena we didn't predict and barely understand. 3 Atlas might be another surprise. Something natural but so unusual, so unexpected that it challenges our models and forces us to expand our understanding of what's possible. Or it might be the biggest discovery in human history. First confirmed contact with technology from beyond Earth, evidence that we're not alone, proof that other civilizations exist and some of them achieve interstellar capability. We'll know soon. The data is coming. October 3rd, December 3rd, March 2026. 3 dates that might change everything.